All right, so 7 gave us 2 square matrices, same dimensions, they're 2 by 2s, and they asked for AB and BA. Now, when I do that just with straight numbers, 6 times 8 is the same as 8 times 6. But with matrices, like earlier when they weren't the same dimensions, I got 2 answers that were by definition different. Here, both of my answers will be 2 by 2. So it is possible sometimes for these two things to be equal. And the special case, when they multiply to give you the identity matrix, the diagonal of ones with the zeros, then we call those multiplicative inverses as long as it's true both ways. So let's see what happens with AB and then with BA. So A times B, A is going to go down here. And then B is going to go up here. And I'll go ahead and label this one since we're doing multiple. All right, now through the magic of the computer, but I put them in the wrong spots. I just wanted to do this before I wrote everywhere. And then this one we will label as BA. All right. So with using our tree crashing analogy, which one I put where makes a difference. And with square matrices, it's easy to get it backwards because you can multiply them either way. But a lot of times we ask you to do it both ways, so it'll work. All right, so crash 2 times the 1, 6 times the -3. So that is going to be 2 minus 18. Now crash it down to the next floor. 2 times 0 is 0. And then 6 times 5 is 30. All right. Now we're going to take our tree 4, 1 and crash it through. 4 times 1 is 4. -3 times 1 is -3. And 4, 1 crashes through to the 0, 5. 0 plus 5. Okay, so AB is -16, 1, 30, and 5. So I read that row and then row. All right, let's see what happens over here with BA. So now I'm taking the column 1, 0, and it's going to crash through these 2 floors. So that is going to be 2 times 1 is 2, plus 4 times 0 is 0. And then 1, 0 crashing through to the 6, 1. 1 times 6 is 6. 0 times 1 is 0. So we're going to get 2, 6 there, which is the first column of matrix B. And the column in matrix A that we're multiplying by was 1, 0, which is an identity row column. So when you see a row like that with only 1, 1 and a bunch of zeros, expect to see the column or the row, one of the things show up. Now our other one, -3 crashing and 5 crashing, so -3 times 2 is -6. 5 times 4 is +20. And then -3 times 6 is -18, plus 5 times 1 is 5. All right, now we're just going to clean this up. So I have 2 and then +14, and then 6 and -13. So those are very, very much not the same. Now, if they came out to be the identity matrix, then that means A and B would be what's called multiplicative inverses. And when we can find the multiplicative inverse, we can make use of that. All right. Now the last one, the book decided we need a application problem because of course this is what a farmer does with his roadside stands. A farmer sells organic zucchini, yellow squash, and corn in 2 different roadside stands. Matrix Q represents the number of pounds of each type of vegetable sold at each stand. And then notice they gave us the lovely labels. So each of my columns is the pounds of each particular vegetable, and each row represents the stands. So stand 1 sold 42 pounds of zucchini, 40 pounds of squash, 84 pounds of corn. And then we have the numbers for stand 2. Matrix P gives the price per pound of each item. Now take a look at P. It is a column with $4 for zucchini, $3.40 for yellow squash, and $4.20 for corn, the price per pound of each item. And now they tell us find the product QP and interpret the result. So first, let's find the product, and then we'll interpret like what those things mean. Okay, so 42, 40, 84, and 30, 36, and 90. All right, and then on top, because I wrote really big, we have $4, $3.40, and $4.20. Yes, I will be using my calculator. All right. So I have my column here, P. And when it falls over to start crashing through, so the first one that it crashes through, that row is stand 1. All right. So I have these price per pound crashing through stand 1 when I multiply. So that first entry is going to be 42 times $4 plus 40 times $3.40 plus 84 times $4.20. All right, so what was the $4? Zucchini. What was the 42? Zucchini. Ha ha ha. And that 40 is our yellow squash times the price of yellow squash. Our 84 was corn times the price of corn. All right, let me go ahead and write the other row. So 30 times 4 plus 36 times 3.4, 40 plus 90 times 4.20. All right, so when I take my pounds and I multiply it by the price per pound, what am I left with? Money. So this is money, 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 money. How much money? There's my calculator already. 42 times 4 plus 40 times 3.40 plus 84 times 4.20. So we get 656.8, but this is money, so I'll go ahead and write 80. And now 30 times 4 plus 36 times 3.40 plus 90 times 4.20 and 620.4, but again, we know that's money, so we'll make it 40. All right. So I have QP here. And just so you know, Q here is quantity P here is price. So the quantity times the price gives us the money that they got in. So this is the earnings for each stand. The first stand earned more than the second stand. Stand 1 earned $656.80. Stand 2 only earned $620.40. Still together, that's not a bad haul. All right. So that is our last question. I'll go ahead and post this. I will be available tomorrow during office hours. I will be posting a digital copy of the review that you guys have on ALEKS. So you don't have to do it separate, but I'm posting that. So if you do have questions about a particular question, we've at least got that where we can both look at the same problem. Alternatively, you can come and screen share and then I can see the exact problem you're working on. All righty. Ta-ta.